In this video, we'll start talking about the delayed infill. This is an advanced topic and most viewers will not need it, so feel free to skip it. In the previous videos, we have been placing infill metal right on top of the metal powder. This works fine when the crucible is small and warms up quickly, and the infill metal melts quickly. And when our powder and infill atoms diffuse slowly, like tungsten and copper, then it works fine. But when our crucible is large and warms up slowly, and the infill metal melts slowly, and when our powder and infill atoms diffuse quickly, like copper and tin, then the powder may get infilled incompletely or unevenly. This is because of the diffusion. At high temperatures, atoms can migrate from one material into another, even when both materials are solid. When the molten infill touches the powder, the atoms start to diffuse. Atoms from the infill diffuse into the powder, and atoms from the powder diffuse into the infill. As the molten infill absorbs more atoms from the solid powder, its melting temperature goes up. And when it reaches the current temperature, it freezes. If this happens when only half of our infill ingot has melted, then only half of our powder would get infilled. To solve those problems, we need to delay the start of the infilling until enough of the infill has melted. There are several ways to achieve this. Today we'll talk about two of them. In the Puddle+Anchor method, we place the infill ingot not on top of the collector, but on the opposite end of the crucible. And it's better to put a thin plate under the ingot to prevent it from denting the sand. Then we tilt the crucible slightly towards the collector. When the ingot starts melting, the puddle of molten metal starts forming near it. Despite the tilt, the puddle doesn't separate from the ingot because of the surface tension. So here our ingot acts as an anchor. When the ingot has melted almost completely, the puddle of the molten infill will run downhill. When it reaches the collector, it soaks the powder rapidly. Because the infill time is so short, the atoms don't have much time to diffuse, so we obtain an even distribution and a uniform alloy. In the Puddle+Stand method, we place an ingot on top of a stand, such that the forming puddle doesn't touch it, and we tilt the crucible slightly away from the collector. Because of the tilt, when the ingot starts melting, the puddle of the molten metal will start to form away from the collector. When enough of the ingot melts, the puddle reaches the collector and attaches to it, and absorbs into it completely despite the tilt, again because of the surface tension. Compared to the anchor method, the stand allows using more infill for the crucible of the same diameter, but part of the ingot will remain unused. There are several other delayed infill methods. We'll talk about them in the following videos.